everyone, welcome back to our channel. This is Om from Civil Center, and today we are going to learn how to make a model in Tekla Structural Designer. So let's have a look. How does the interface of TSD looks like? I'm sharing my screen. And now, first of all, we will create construction levels in model. So to create construction level, we will click on Insert Below. To create a foundation level, base will be our plinth level, and then we will insert above the ground floor roof level and the first floor roof level. We will rename it as foundation level, plinth level, ground floor roof level, and first floor roof level. We will change this to SSL, that is slab level, and this is top of foundation. Our plinth level is 1.2 meter below. Our foundation level is 1.2 meter below our plinth level, so we will insert that. Similarly, our ground floor roof level is 3.2 meter above the plinth level. We will change that, and again the floor to floor height is 3.2 meter, so we'll change that too. We can provide the slab thickness here 125 mm and 125 mm. We won't provide a slab level on the plinth level as there is no slab casted here. So our construction level is now ready. We will click on OK. We will go to the levels and open all our levels. Our plinth level is already open, so we will open now for foundation level, ground floor roof level, and first floor roof level. Plinth level, foundation level, ground floor roof level, and first floor roof level. We will go to the foundation level and then go to the grid, import the DXF file to get the center line diagram. So we will choose the center line and import it. We will choose the architectural grid by layer, and we want this center line in all the floors. So as you can see, we have imported center line in each level. Again, we will go to the base level, which is our plinth level, and import the DXF file. Now we want shadow of our plan. So here we have shadow of our plan. It means you can't do anything over here, but you can just check it. Now we will go to concrete and define columns. So in the properties box, we will define our columns. We will change our grade of concrete to M25. We will define the size 250 by 250. This is just our assumption. In case our column will fail, we can make the changes. We will turn off the automatic alignment, and then we will choose our grade of steel to 500. So our column is completely defined. Nominal cover is 40 mm, which is correct. So now that our column is defined, we can assign our columns here at the desired place. This is our secondary beam, and in this model, we will ignore this. We will just consider our main beams. So I guess all the columns are placed correctly in our model. We will go to the foundation level, and then we can see we have our columns at the correct place. So you can see here our columns are ready. Now we will go to the plinth level and define beams here. So in the properties box, we will define our beams. We will choose the concrete as M25, then section of beam 250 by 300, grade of steel as 500, now just because we are ignoring our secondary beams, so we can assign our main beams by just a simple drag. In case you want to assign your secondary beam, then you will start by assigning the secondary beam, and after that you will assign the main beams. Now just have a 3D look. Our beams and columns are properly assigned. We will go to the construction level and we want the same thing in our ground floor roof level. So we will just go change the source of ground floor roof level. We will make it base and then click OK, and you can see the same beam column diagram is copied in ground floor roof level. You can have a 3D look over here. Now, we don't have a slab at plinth level, but on ground floor roof level, we do have slabs. So we will cast slabs on ground floor roof level. We will go to the 2D diagram of ground floor roof level and then go to the slabs. So we will choose slab on beams and we will assign our slabs quickly. Now we will have a 3D view. See, we have done a mistake here. We haven't changed the source. So whatever changes we are making in the ground floor roof level, the same changes are being made in plinth level. So first of all, we will undo it. We will go to our construction levels, make it unique, so that whatever changes we make here restricts here. Now we will go to the ground floor roof level and then assign slabs. We don't need to define our slabs, as the predefined slabs are as per as our requirement. Now we will have a look at 3D drawing. We have our 3D drawing here. We will go to the first floor roof level in construction levels and change the source to 1, which is our ground floor roof level, as we need the exact drawing as ground floor roof level in the first floor roof level. So everything is done here. Now all you have to do is to make a headroom here. So we'll go to the construction level. We will insert above a headroom roof level. Headroom roof level. Headroom will have a floor-to-floor height of approx 2.5 meter and the slab thickness would be 100 mm. Rest is okay. So we will click on OK. I'm sorry. I again did the same mistake as the previous one. What we changed made it unique. Now insert above. Then headroom roof level. I'm sorry for the mess. Change the spacing to 2.5. Then keep the source unique. Slab thickness 100 mm. And now click on OK. Okay. So we will choose the columns that are required to increase up to headroom level. We will choose the specified height and our columns are ready here. We will assign the headroom level here and then we will just define the beams. In beams, we have to change the grade of concrete to M25. Then our size is predefined 250 by 300. Then grade of steel Fe 500. And now we can just drag and create our beams, and we can also assign the slab on it. Let's have a look at the 3D structure. So our Tekla model is now ready. Now, just to validate it. So validation is okay. We will go to the load now. And in load, let's go to the prince level, choose the dead load. On the outer walls, we have to assign the loads. We will change the load to 11 kN per meter and assign it on the external walls. And on the walls around headroom. Let's see whether it's correctly assigned or not. So it's correctly assigned. Now we'll again go to the plinth level and mark the loads to 5.5 kN per meter for the internal walls. Let's see if they are assigned accurately or not. So yes, I guess everything is fine here. 11 kN on the outer wall and 5.5 kN on the inner wall. Okay. Now we will go to the ground floor roof level and copy the loads. So we will define dead load of full UDL 11 kN per meter on external walls. And on the beams around headroom. Then we will assign a load of 5.5 kN per meter for the internal walls. We will also have an imposed load at this floor, which is live load. So I will choose the level load and apply it. You can see our dead loads are assigned here. Our imposed load is also assigned here. Now we will go to the first floor roof level. On the first floor roof level, we will have parapet wall. So we will assign a dead load of 3.5 kilonewton per meter. On the outer walls of the roof. We will skip these two walls because here we are going to make headroom, which is having a load of almost 11 kilonewton per meter. This floor will also have an imposed load of 2 kilonewton per meter, and I will apply it 2 kilonewton per meter level load. Let's check it. It's 5 kilonewton per meter square. Let me change it. The live load should be 2 kilonewton per meter square. And then let me change this one again to 2 kilonewton per meter square. Now, let's check the dead load. So this is our dead load. So in this video, you are also learning how to correct your mistakes if you have done any. Now, so you have an imposed load over here of 2 kilonewton per meter square and here of 2 kilonewton per meter square, which is good. But you will also have a live load of 2 kilonewton per meter square on this slab level. But apart from that, you will also have, if you are having a water tank, then you can have a load of that too, which is a varying load. So you can consider that as a live load. So we'll assign a live load on headroom roof level, and that load will be of 5 kilonewton per meter square. So we will choose imposed load the level load of 2 kilonewton per meter square. I'm sorry, it's of 5 kilonewton per meter square. Let's have a look at it. So it's still showing 2 kilonewton per meter square. We can change it from here. We will make it 5. And now it's 5 kilonewton per meter square. It's 2 kilonewton per meter square, and it's 2 kilonewton per meter square. We will check for the dead loads. Our dead loads are properly assigned. This one is our external wall, and this is having a load of 11 kilonewton per meter. Our internal walls are having a load of 5.5 kilonewton per meter, and our parapet wall is having a load of 3.5 kilonewton per meter. So it's perfectly fine. Now we will go for the seismic load. We are skipping the wind load because the total height of this project is, I guess, 8.9 meter. We can check that in our construction level. Yeah, so the total height is 8.9 meter of the superstructure. So we will, and wind load acts only when your building is higher than 10 meters. So we can skip the wind load here. In the coming classes, when we will go for the highest building, we will apply wind load on that. Let me close it. Everything is unique. Okay. Now, in the load section, go for the seismic load, seismic wizard. Code spectra is fine. Click on next. Here, ignore the seismic in floor and below. So ignore the seismic load for the foundation level. Now, we are in Bhubaneswar and our zone comes in zone 3. So our seismic zone is zone 3. We'll choose medium soil, as here we have medium soil, and the importance factor will be 1 because it's a residential building. Click on next. There is no plan irregularities, so we will simply click on next. Our structure type is RC-MRF building without any masonry infills. Same is here. Now, seismic force resisting system. So for both the direction, it will be a moment frame system. Then we will transfer the loads. So self-weight excluding slabs, okay. Slab self-weight, okay. Dead load, choose this. Service load, ignore this. Imposed load, choose this one. And click on next. Because we have not defined any service load in this project. Include localization? No, we don't want to include the localization. Click on finish. Then scenario will be operating. And next. We will use limit state method, so we will ignore the working stress method here. Click on finish. Validate this. Now we will go for the load combination. Here we will generate it. Scenario will be operating. Click on next. We will choose the limited state method and ignore the working stress method. So we will uncheck the boxes and click on next. Next. And here we will click on finish. Now click on OK. Validate this structure and let's analyze it. To analyze it, we will go for analyze all static. Now we will design it. Our analysis is complete. This Tekla Structural Designer is a very simple software and it's very fast and efficient. So it won't take long time in analysis. So now we will go for the design part. In analysis and design, we will click on design all static and let it design. So here you can see different colors in our model. Green stands for pass, yellow stands for warning, and we also have a red here. That means this member will fail. So how to redefine it? Like how can you make all the members pass? That we will learn in our coming classes. So stay tuned. We will get back to you as soon as possible. So how to here. So some members are passing, some are giving warnings, and some are failing. Like in our model, this one member is failing. In our coming classes, we will learn how to change this and make all our members pass. You can ignore the warnings, but you can't ignore a member which is failing. So that was all for today. Thank you.